Hello and welcome to OKellyChemistry.com. I'm Ivana O'Kelly and thanks for joining me. In this video I'm going to talk you through how to answer questions as they relate to trends on the periodic table. I'm going to cover 3 trends. First will be ionization energy, and that increases as we move up the periodic table, and it also increases from the left hand side of the periodic table all the way over to the right hand side. The second one will be atomic radius. So atomic radius will increase as we move from right to left, and it will also increase moving down a group. Our third trend is electronegativity. Electronegativity will increase as we move up a group, and it will also increase as we move from the left hand side to the right hand side, stopping at fluorine. So our noble gases are not involved in electronegativity. So go ahead and grab that periodic table and let's answer some questions. So let's do a quick review of these 3 trends. The first, ionization energy, is the energy required to remove the highest energy electron from a neutral atom. And these arrows here in the white box represent the trend for ionization energy in terms of increasing. Next is atomic radius, and that is 1/2 of the distance between the center of 2 neighboring atoms. So when the atomic radius is measured, it's measured as the distance between the center of 2 neighboring atoms of the same element. And finally, we have electronegativity, and in electronegativity, it's the measure of the ability of an atom in a bond to attract electrons to itself. And obviously the element that has the higher electronegativity value is going to win, and it's going to be able to pull the electrons closer to it. Now, in terms of the general trend as we move across the periodic table, our Zeph is increasing, and Zeph is related to our positive nuclear charge. So it increases as our shielding remains constant, because when we move across the periodic table, we're adding electrons to the same energy level, so our distance from the nucleus is the same. When we move down a group, the energy level is going to increase, so that means we are at a greater distance from the positive nucleus to the outermost orbital. So first question, ionization energy tends to increase. So here's a periodic table, so what I would suggest you do is you actually go ahead and draw in the trend on the periodic table. So ionization energy will increase as you move up a group. It will also increase from left to right. So looking at our answer choices, we can eliminate A and B. So then that narrows it down between C and D, because it begins with up a group and we see that it's left to right. So therefore our answer choice is going to be C. Next question. Atomic radius tends to increase as U. So with atomic radius, we know that it increases from right to left, and it also increases as you move down a group. So we can eliminate the ones that are up, and now we have to choose between A and B. So down a group and from right to left, so therefore our answer choice is going to be A. This question is dealing with ionization energy, but this time we're talking about it in terms of how it decreases. So it decreases as we go down a group, and it decreases from the right hand side to the left hand side of the periodic table. So down a group are A and B, so we can cross out C and D, and we see that it's moving from right to left, so the answer choice here will be A. Next question. Which of the following elements has the greatest ionization energy? So we have 4 elements, so let's go ahead and put them into our periodic table. So potassium is in group 1 and it's in period 4. Next is rubidium, which is underneath potassium. Calcium is to the right of potassium, and strontium is below calcium. So greatest ionization energy, again the trend, it increases moving up, it increases left to right. So we are looking for the element that is highest up and furthest right, and that's going to be calcium. Electronegativity. Where does it increase? Well, again, fluorine has the highest electronegativity value, so it's going to increase from left to right, and it's also going to increase as we move up a group. So we can cross out A and B. So up a group and left to right, that means we have C. So this question is asking which element has the greatest electronegativity. So electronegativity, we know that fluorine has the highest, francium has the lowest. So answer choice here, we see that we have fluorine. So that's going to be our answer. Now with this question, we need to place the following elements in order of increasing electronegativity. So let's go ahead and put them into our periodic table. So sulfur is in group 16, period 3. Oxygen is above it. Sodium is in group 1, period 3. And aluminum is in period 3, group 13. So ultimately we need to put these in order. So we'll move left to right. So it will be sodium, aluminum, sulfur, and then oxygen. So again, we're moving towards fluorine, and that's why we put them in this order. So this question, which of the following elements has the largest atomic radius? So because we're asked for the largest, let's put in the increasing trend for atomic radius. So it increases as we go down, and it also increases from right to left. So silicon is in group 14, and it's in period 3. Next is sulfur, which is in group 16, period 3 also. Strontium is in group 2, and it's in period 5. Selenium is in group 16, period 4. So that means that it's going to be under sulfur. So which one of these has the largest atomic radius? We are looking for the element that is furthest left and lowest on the periodic table. So that's going to be strontium, group 2, period 5. So this question reads, which of the following elements has the largest atomic radius? So let's go ahead and find these on our periodic table. So oxygen, fluorine, sulfur, and chlorine. So they're right beside each other. Again, we need to find the largest atomic radius. So we're looking for the element that is furthest left and lowest. So that's going to be sulfur. So with this question, we want electronegativity. And electronegativity, where and when does it decrease? So again, fluorine has the highest electronegativity. So it's going to decrease away from fluorine. And it's going to decrease as we move down a group. So down a group, we have to pick between A and B, and it's going from right to left. So therefore, our answer choice will be A. So as a review, here are our reasons why these trends happen. So our ZEF is increasing across, our shielding is remaining constant. As we move down a group, the energy levels are increasing, so there's a greater distance from the positive nucleus to the outermost orbital holding our electrons. Again, our definitions: ionization energy is the energy required to remove the highest energy electron from a neutral atom. Atomic radius is 1/2 of the distance between the center of two neighboring atoms. And electronegativity is a measure of the ability of an atom in a bond to attract electrons to itself. So these questions are actually from a quiz, which is part of a course at okellychemistry.com. So ladies and gents, you want to find out some more information about periodic trends, hop on over to okellychemistry.com, and hopefully I'll see you soon. Bye-bye.